Quadratic surfaces. A set of lines parallel to a given line passes through a given curve is known as a cylindrical surface or cylinder. The parallel lines are called rulings. Okay, so the first part of this, a set of parallel lines to a given line passing through a given curve is known as a cylinder. So, if we see something like this, and see we have one line that's to the curve there, and it says it's passing through the given curve, and that's the line here I just created. I'll do it in a red. That's the line we created. Now all the other lines are going to be parallel to that. Oops, it's a terrible parallel line. So that's why when we see this shape, it's called a cylinder. Now one thing that's a little different here is we never realize that that's not it. If I look at this line, or that curve I should say, that's also a curve. And I'm going to create a line parallel, not parallel, but passing through the given curve. And now I'm going to create a set of parallel lines from that one. And what we see here is we see that's also a cylinder. And that's something that's probably far from our minds as far as a cylinder is concerned. Now, what if I had something like this kind of curve? And I said, okay, let's create some parallel lines to this one. So I could, let me move this down a little bit. I could say, okay, let me do this. There is, oops, let me do it in my other color here. There is a line passing through that line. Now, I will have another one back here, won't I, about the same? That's kind of tough making about the same. Oh, I got it, hang on. There we go. Now I'm just gonna start drawing a bunch of parallel lines to that line. And I don't want to touch it because I want to make sure you see the separation of that. These lines can be really weird sometimes. Visualizing these can kind of be hard. Okay, so there it is. So there's another one. Now those are all cylinders because they follow that definition. So it's kind of neat there about how we talk about these. Now we can actually talk about equations of these. And remember, these other lines I created are called rulings. So now we're going to look at the idea of equations for these. So let's take this cylinder, for instance, and let's put it on a rectangular coordinate system. Not the rectangular coordinate system, but the 3D coordinate system. That looks pretty centered. So now if I look at this here, I can see that I have like this circle around here. I'm going to push a little bit more so I can have a nice little equation here. So I'll do one more on the end there. So that's what we're looking at here. And it looks like it goes out 1, 2, 3, 4, 5. So it looks like that radius is about 5 there. So I'm going to put that in there. So now the equation for this thing, think about what it would be. If I flip this thing sideways and just looked at the XY plane, and in general, if I'm dealing with a circle of radius 5, if I'm just looking at this piece right here, then I would say that that's x squared plus y squared equals 5 squared. Now, since I'm actually talking about a cylinder here where I actually have z, it's actually going upward, then that doesn't add anything more to this. Essentially, I'm just dealing with this equation, x squared plus y squared equals 25. So one thing you'll notice when I'm dealing with these cylinders is even though this is a three-dimensional equation, and it's hard to tell because that only looks two-dimensional to us because it only has an x and a y in it. As soon as I put it on a 3D coordinate system, it actually becomes a 3D surface. And this is a cylinder. So this is actually the equation for this cylinder here. Now if it was 2D, it would be a circle if I was dealing with the XY plane, but I'm not. I'm dealing with the X, the Y, and the Z. So that tells me here that it's going to be a cylinder in the 2D space, which is down here. And then since I added that third dimension, it just shoots it all straight up and just keeps going. So for instance, now I'm going to talk about a parabola. So now I look at this parabola, and I'll assume that this is 1, and this part here, this part here kind of follows the parabola we're accustomed to, and that's y equals x squared. Now again, remember, this is my xy plane down here. So if I look at that, it would be y equals x squared for that bottom piece right down here. I was just looking at the parabola on the xy plane. So that's the idea of that. Now again, I'm projecting it upward, right, into the z. Now as soon as I put this on there, it fills all of this in here. It's that same shape, and I'm just taking that same shape all the way up and all the way down. And that's the idea of what we're dealing with here. So this, if I talked about it in 2D, would be a parabola. And that same equation in 3 dimensions actually gives us this cylinder. So what you'll notice with all of these cylinders, these equations we come up with are going to be mostly 2-dimensional. Would I say always? I don't know. Can't say that yet. So just kind of keep that in mind as we go through these. If I have 2 variables, in most cases I'm dealing with a cylinder.